All right, you guys, this is the review for our third 9 weeks exam, or the spring midterm. I'm going to work just the odds, and but the key will be posted on all of our websites. All right, so starting with number 1, let me grab a formula chart real quick. Okay, so when you look at these shapes, obviously they're labeled rhombus, rectangle, parallelogram, etc., etc. But your formula chart has multiple pages, and one of the pages is this parallelogram chart. So if I was to look at number 1, number 1 is a rhombus, and you guys are only going to get what is printed on this page, not anything I write. But whatever I write, you might want to write on your own chart, just so you can use it to study and help you read that and learn how to use it so that it's beneficial on the test. Since number 1 is a rhombus, I'm going to go to the rhombus shape and read all of the checked properties that it has. So it has opposite sides parallel. When I think about parallel opposite sides, I could pull out alternate interior angles that are congruent. That's the one thing that I'm going to look for when I see that check mark. Opposite sides congruent would be like, hey, those two are congruent, and then the other two are congruent, and we'll use that property on another one. The third check mark, it goes with opposite angles congruent. So a picture that goes with this one would be those angles are congruent. Consecutive angles are supplementary, means that the neighbors in a picture, those two circled ones, would add up to 180. We do not have 4 right angles in a rhombus because that would make it a square, but we do have 4 congruent sides. So all of the outside pieces, not only opposites are congruent, but all 4 are congruent to each other. The next check mark says that the diagonals bisect each other. So diagonals bisect each other would have tick marks on the inside diagonals. That's what that would look like. And then the next one, diagonals perpendicular. So we don't have right angles on the corners, but in a rhombus, you have right angles in the inside. So where those diagonals meet is where they make 90 degrees. One good indication in a rhombus type question is that that center angle will be missing and there's not enough information to find it. That should be an indication of, hey, that's the one I memorized. It has to be 90. And then the last one is that the diagonals bisect the angles. So in one corner of a rhombus, here's a diagonal. That means that the top is equal to the bottom in the picture. Same thing on this side. Top is equal to bottom, and then the other diagonal, the left, is equal to the right, and so forth. When you have diagonals bisecting the angles, that means your line of symmetry is the diagonal. So you can fold the shape over the diagonal and everything lines up. Fold the shape over the diagonal and everything lines up. So if we look at the actual rhombus shape, on number 1, I'm going to fill in the angle they gave me. This is 34 degrees. Okay, when I use my idea of the diagonals being the lines of symmetry, if I use this as my line of symmetry and fold that 34 degrees down, it lines up with angle 7. So I would call angle 7 34 degrees. And then if I use the other diagonal, fold this way, these two angles, the 34s, line up with 1 and 2, which makes angle 1 34 degrees and angle 2 also 34 degrees. So in a rhombus, all 4 opposite of each other are going to be the same, which means I can go ahead and conclude 3, 4, 8, and 9 are going to be the same. I just need to find one of them first. So in my answer, I'm going to go ahead and put that 1, 2, 6, and 7, which 6 was given, are 34 degrees. Now I'm kind of stuck. I have no way to find 3, 4, 8, and 9. I have no way to solve for angle 5. This is my indication that 5 is one of those that I've memorized. So that tells me that this angle right here is a right angle, 90 degrees. And now we have this rhombus is split into 4 triangles. The thing I know about triangles is that those angles add up to 180. So I'm going to type in 90 plus 34, 90 plus 34 is 120. That doesn't mean angle 3 is 120. That means that I need to find what's left over after I subtract that 124 out from 180, which leaves me a 56 degrees. And now I can say, okay, 3, 4, 8, and 9 are all 56 degrees because I can fold it across and I can fold it down and see what lines up. So 3, 56, angle 4 is 56, and 8 and 9 are both 56 degrees. All right, number 3 is a parallelogram. Parallelograms, the only things that we can use to come up with angles are that our alternate interior angles are congruent and opposite angles are congruent and neighbor angles are supplementary, but the most used thing is going to be this alternate interior, and that's actually the first one I'm going to pull out. Alternate interior to 25 would be this bottom corner that doesn't really matter if I need. That's not one they asked me for. Alternate interior to 31 would be 3, so 3 is 31. Alternate interior to 64 would be angle 1, so angle 1 is 64 degrees. And then I get stuck. Once you get stuck, you need to use the fact that all angles in a triangle add up to 180. So for example, I have more information in these top and bottom triangles, so that's where I'm going to start. And I'm going to take 180 degrees and subtract out 25 and 31, which leaves me 124 degrees for angle 4. Then I'm stuck. I need to move into the next triangles. Anytime you move into the next triangle, you want to do it at the center because 6 and 4 are a linear pair, so they add to 180. So if I take 180 and subtract out the 124 that we have here, that gives me 56 degrees. And now I have 2 out of 3 angles so that I can find this in angle 2. So I'm going to add 64 and 56 and subtract that from 180, which gives me 60 degrees for angle 2. So angle 2 and 5 are alternate interior, which tells me that 5 is also 60 degrees. So angle 1, I'm going to write 64 degrees. Angle 2 is 60. 3 is 31. 4 is 124. 5, I can't see. Oh, there it is. 60 degrees. And then angle 6 is 56 degrees. Number 5 is another parallelogram. So again, we'll do the same thing. Find your alternate interior first. Alternate interior to angle 41 degrees is 5. So 5 is 41 degrees. Alternate interior to 75 is 1. So 1 is 75 degrees. I have most information in the left and right triangles. So I'm going to solve for the missing angle by adding them up and subtracting from 180. So 75 plus 41 subtracted from 180 gives me 64 degrees for angle 6. To move in to the next triangle, we need to subtract from 180 the 64 to get 116 for angle 4. And then now I know that 116 plus 18 subtracted from 180 will give me 46 degrees for angle 3. Since 46 and angle 2 are alternate interior, they're going to be the same measure. Alright guys, on the next page, number 7, we have a trapezoid. It is not asking us to find the area of this trapezoid. It's asking us to find x. Well, x is on the segments, the bases, and this middle segment. This CD is called a mid-segment. And the mid-segment theorem is that first page, top formula. It says mid-segment equals base 1 plus base 2 divided by 2. In my problem, the mid-segment is 5x. So instead of putting m equals, I'm going to replace what it is actually equal to. So that would be 5x equals base 1, we could call 2x, plus base 2 is 7x plus 3, and that whole right side is divided by 2. So this is base 1 plus base 2 divided by 2. Go ahead and consolidate your like terms on the top. So that would be 5x equals 9x plus 3 divided by 2. When I read this equation, the divide by 2 part is the part that throws me off. So that's the part I want to get rid of first. The opposite of dividing by 2 is to multiply both sides by 2. So the left side would give me 2 times 5x, which is 10x. The right side, the reason I multiplied by 2 was so that it would cancel out with the bottom one and just leave me whatever was on top. So that would be 9x plus 3. So again, combine your like terms. We would subtract 9x from both sides, which leaves me a 1x equals 3. So my x is 3. The second part of this wants us to find AB. Well, if x is 3, then AB would be 2 times 3, which comes out to 6. All right, number 9. Number 9 uses the idea that we have a parallelogram, and more specifically, it is talking about PS, SR, RQ, and QP. These two letters with no bar above it mean the lengths of the sides. So this side is 5x minus 2y, SR is 3x plus 5y, RQ is 28, and QP is 23. One thing I know about sides of a parallelogram, if you go back to your chart, parallelogram, the only things that talk about the sides are opposite sides are parallel and opposite sides are congruent. Parallel sides just tell me things about angles. It doesn't tell me anything about their measures, but opposite sides being congruent means I need to set the opposite pieces equal to each other. So that would mean that 5x minus 2y is equal to 28, which is across from it. And when I first write this equation, I'm kind of confused by it because I don't really know where to go or what to solve for. So this is an indication of, hey, let's go ahead and write both equations, one on top of the other, and see if it sets it up for something that I know what to do. So then I'm going to go ahead and write the other equation. These two pieces are equal, so that would give me 3x plus 5y equals 23. When I look at this problem, those two different variables in the same equation tells me to solve with either substitution, elimination, or graphing. This one is probably more easily set up for elimination. So let's say we were going to cancel out the y's. I'm just choosing y's because I want to, but you could eliminate the x's and get the same answer. If I'm choosing y's, I'm going to multiply the top equation by 5 and the bottom equation by 2. I'm not multiplying by negatives because my y's are already opposite signs. So we'll have to distribute. 5 times 5x is 25x. 5 times negative 2y is negative 10y. And 5 times 28 is 140. Do the same with the bottom equation. 2 times 3x is 6x. 2 times 5y is a positive 10y. And 2 times 23 is 46. So we'll add these two equations together. 25x and 6x is 31x's. The y's cancel, and 140 plus 46 is 186. To solve that for x, I'm going to divide both sides by 31, and I get x equals 6. Now to find y, I'm just going to pick an equation and plug back in. Let's say we use the second equation, so instead of 3 times x plus 5y equals 23, I'm going to plug a 6 in for x and then reduce. 18 plus 5y is equal to 23. So I'm going to subtract 18 from both sides. Sorry, y'all can't see that. Which gives me 5y equals 5. Divide both sides by 5, and I get y equals 1. Just because you have a parallelogram and information about diagonals or sides does not mean it's going to be a systems equation where you either solve by substitution or elimination. The only time you use those methods is when you have the same variable in this, or two different variables in the same equation, like an x and a y. If you end up writing equations with just x and numbers, that means you can actually solve for x just on its own with your regular algebra. All right, looking at number 11, when I see that this is a parallelogram, I'm going to underline that word and label the pieces they told me. Angle 1 is 42 degrees. Angle 3 is 6x. And then I'm going to ask myself, okay, well, how do those two angles relate if This is a parallelogram. Well, parallelogram tells me my opposite sides are parallel, and I can always pull out alternate interior. 1 and 3 are alternate interior, which means that they should be equal. So I would say, well, 42 and 6x, the measures of those angles, should be equal. So then I can solve by dividing by 6, which gives me x equals 7. Number 13, when I read 13, 14, 15, they all look very, very similar. The difference is exactly what they're asking for. So you want to look at what types of angles we have, what I'm finding. So if I want to find the sum of interior angles, that means I'm going to look at my formula chart and see if I see anything that has sum of interior angles, which is that very, very first formula. Interior angle sum is 180 times n minus 2. 180 times n minus 2. N stands for the number of sides. Well, that comes from this shape that we have. A pentagon is that basic house shape. So you have your sides of your house, and then you have the roof, which is 5 sides. So n is equal to 5. So I'll just plug in. 180 times 5 minus 2 is really 180 times 3, which comes out to 540 degrees for the sum. Sums, you want big numbers. Okay, it's when I ask for each angle that you need to have a smaller number. For example, number 15. Number 15 wants you to find each interior angle. Each angle is not on your formula chart. That's something that you've got to have memorized, but I would write it on your formula chart to make sure you know that you've got to remember it for the test. Anytime you want each angle, whether it's interior or exterior, you want the sum and you want to divide it by the number of sides you have. So if I want each interior, I would take the interior sum formula and divide by n. If I wanted each exterior, then I would take the exterior sum, 360, and divide that by n. Since this one talks about interior angles, I want the interior sum, which is 180 times n minus 2, and divide that by the number of sides we have. With a hexagon, hexagon is n equals 6. So I'm going to plug into my formula. I want 180 times 6 minus 2 divided by 6, which comes out to 180 times 4 is 720. 720 divided by 6 comes out to each interior angle being a smaller angle of 120 degrees. All right, 17 and 19 are the last two we're going to do for this section or this video. Classify the quadrilaterals just means classify these four-sided figures. Okay, your options that you could have for four-sided figures are parallelograms, rectangles, squares, rhombus, kite, and trapezoid. So I want to figure out, based on the markings, which of those six shapes is listed. Number 17 has a 90 degree in the center, which tells me on my formula chart, 90 degrees at the center means that the diagonals are perpendicular. The only two shapes that comes to is a rhombus and a square. So it's either a rhombus or a square. That's what I'm deciding between. Then when I look at the tick marks, it looks like the diagonals are bisecting each other, but they're not the same length. They're all different lengths. If the diagonals are not congruent, diagonals being congruent fits a square, but we want not congruent, which means it should be a rhombus. So this would be a rhombus. Number 19, we have only one pair of opposite sides parallel. That's what those arrows mean. And opposite sides being parallel for both of them fits parallelogram, rectangle, rhombus, and square. So I'm pretty much eliminating this whole left column. My only two options are either a kite or a trapezoid for number 19. If on a kite, remember, kites have 0 parallel sides. trapezoids have one pair of parallel. So this would be considered a trapezoid.